Let's go ahead and get started. So today our main speaker will be Rob Wade. Rob is a place-based educator working in the Upper Feather River region of California's Northern Sierra Nevada, and as a science and outdoor education coordinator and trainer for the Plumas County Office of Education. He successfully integrated stewardship, education, and recreation into the curriculum of all local schools for more than 20 years. This has been through strategic partnerships, innovative programming. Since 2010, Rob has coordinated the Fire Restoration Partnership with the Plumas National Forest. And this included the development of the Sierra Nevada Fireworks curriculum with the Fire Effects Laboratory that's based out of Missoula, Montana. Rob has a BS from the University of California, Berkeley in Conservation and Resource Studies, an MA from the School of Education at the University of San Francisco. And on the line, we also have two educators, Melissa Groh, who teaches 3rd grade at Quincy Elementary School, and Ron Logan, who is recently retired from being a 7th through 12th grade science teacher at Quincy High School. Thanks everybody for joining. As I mentioned, this will be recorded and we will be doing questions at the end. And with that, I'm going to change presenters so that we can have Rob tell us all about this great program.
Okay, I believe I am live and on, so unless Stacy tells me otherwise, I'm going to begin. Thank you very much, Stacy, for that introduction. I also want to welcome Ron Logan and Melissa Groh, two educators who I work with in the region. And it's a pleasure to have them on board as well to be able to share some of their own insight in more daily and annual work with students. So you all obviously know this description, so I'm not going to sit with that, but obviously we're going to kind of get into the mix with fire. I do want to quickly call out Alana Abramson from the Fire Effects Laboratory, who coordinates the fireworks program out of there that has several versions that we're going to be talking about, but the specific one here will be the Sierra Nevada fireworks curriculum. And that's one of the primary tools that we are using in Plumas County, and that we're also trying to share out other places. But fire is definitely the phenomenon, an issue that we're all involved in and engaged in, whether we are looking to teach about it or we are land managers working for agencies or nonprofits in the field. And so I know that there are going to be some things I cover that you are an expert in, and other areas where you are going to be brand new and green. And so I'm going to just try and do a fair coverage of all of these things and hope that it fills in some of the gaps as we talk about how we bring fire into our schools and into the curriculum more effectively. Now, obviously, I have just a few images here. Fire, not all, fire ends well. There's just a little comic strip I stuck in here, and obviously quite tongue-in-cheek, but fire has been around a long time to cook warm and all. But now mostly when we talk about fire, we're talking about catastrophic fire. Fire that just makes a huge impact when it comes into our lives. And especially, I know this image is very compelling when you're looking through the timbers of a home at a raging fire. And I know this is a lot of what drives a lot of the interest as well as the funding around fire in the state of California and federally. But all fire is not catastrophic like that. Fire is very beneficial, and as we all know, it's been around forever. And it's been used by Paleolithic people and the many tribes in California being one of the most diverse Native American populations in North America. And fire was a critical part of their lives as well. So there's a lot of different places to engage fire, both on the science as well as the social studies and history aspects. So I was already introduced. I'm not going to really go over this too much. All of this information is already quite shared. But I do want to give a little geographic context to where we are. Plumas County is in northeastern California in the Upper Feather River watershed. We are at the meeting point of the Northern Sierra Nevada, the South Cascades, and the Great Basin. So it's a very interesting, diverse area. And it's the one watershed in the Sierras that actually cuts through the Pacific crest. And so the watershed headwaters begins to the east of the crest, but then drains all the way to the ocean. We're lower elevation, 8,000 to 2,000 feet. So some of what we do around fire in our area it would have to be shifted to subalpine characteristics in the southern Sierras and otherwise. And of course, if we look at coastal or different areas of California, each area has its own interesting and unique ecosystems, forest types that will all kind of skew and adjust all these things that we're talking about. And then ultimately, our area touches both the Plumas National Forest and parts of the Lassen and Tahoe. And so there's definitely some crossing of political and agency boundaries. And this is a mixed conifer forest type predominating. And this is just a couple of quick little images about that area and the dominant communities in this area. I'm really going to start here by talking about the California Science Framework, because this is really the heart of this particular webinar. Is not just about fire science and fire in California as a phenomena, but fire as a phenomena being used in K-12 education, and how does that look like? So I just really want to set the frame clearly. I know we have some educators on the webinar, but we have many who are not. So I'm just going to go over these pieces because I find them to be critical for understanding. One of these is that the next California Science Framework, which just rolled out a couple of years ago, has two primary components that are very important for everyone who is concerned with science and land management and stewardship. One of them is this next generation science standards. It is a big change in science in the sense that it is moving away from having students learn about science and more about students doing science. And so it breaks down into three different areas that they call the 3 dimensions of next generation science. And anybody who wants to work with a teacher in a school, it would do you well to understand this part of what teachers are all wrangling and grappling with in moving into this new science framework that's going on. And then the other part of this, beyond next generation science standards, is this blueprint for environmental literacy. And this blueprint came out a few years ago, was authored by a group that was selected by Tom Torlakson, who is the head of instruction for the Department of Education. And they outlined several environmental principles and concepts that they want all students to be literate in by the time they graduate from high school. And all of these things together are to be driving education and science education in California. So I'm just going to repeat a little bit of this right now. Next generation science standards and the EP&Cs, as they call them. All of us in our agencies and our professions have our little shortcuts and acronyms. And so I just kind of want to frame a couple of those very quickly. So around the next generation science standards and the California Science Framework, the idea is having every student learning every science every year. And it doesn't mean they're going to be covering the full breadth of science every year, but it does mean that students will be diving into physical, life, earth, and space sciences every year. And that's from kindergarten through 12th grade. For many, many years, elementary school was kind of relegated to the back burner. But this new change with the framework actually moves science to the front of everyone's attention, not just math and language arts, but science as well. And again, that other unique piece is that 3-dimensional instruction model, of which there are 3 parts, which I'm going to go over right now. You can see them in front of you. So the disciplinary core ideas is what we would have always just called science in school. But the idea with these DCIs, again, another little shortcut there, is that the science standards that are taught first at kindergarten through 2nd grade are then repeated again 3rd through 5, then 6th through 8 in middle school, and finally 9 through 12th grade in high school. This is very important. So the idea being that students will all be engaging the same concepts and core ideas in science 4 times as they move through their 13-year school career. And so there are many opportunities to bring forward issues and different phenomena in those grade bands. And then they break down essentially into life science, physical science, and earth and space science. And this is often where science would end. We wouldn't get into more details after that. But this is where things change a little bit more with the next generation science standards. Not only do we have these DCIs, or these disciplinary core ideas of physical life and earth, but we also have cross-cutting concepts, the science and engineering practices, and as I mentioned already, the California Environmental Principles and Concepts, these EP&Cs, and they are to be woven together whenever science is occurring. All 4 of these are actually actually woven together. So the normal 3-strand of NGSS is actually amplified up to 4 different dimensions, that we always make sure that what we are learning in science is applied to the environment around us and where we live. There are 8 different practices, and again, these are the things that scientists do, so we want to make sure the kids know how to do the things that scientists do, because we want kids to become scientists. So we have these asking questions, defining problems, developing and using models. You can see all of these in front of you. These are all steps and practices that are employed by scientists in all areas of science and engineering. And in order for kids to become competent and literate in this area, they need to be applying these, even beginning in kindergarten. So this is the new model, that when you are studying life, earth, or physical or space sciences, you are always going to be engaged in one of these practices at all times. And this is how it's kind of a blue color coding in the way that it's framed here. The third dimension of next generation science is the cross-cutting concepts. There are 7 of these, and you can see them in front of you. The idea is, if you are looking at fire, since that's what we're talking about here, that we would be looking at fire through the cross-cutting concept or the lens of patterns or cause and effect, scale, proportion, and quantity. And so these are all different areas that students will be looking at, their different science areas and inquiry as they go through year after year after year of science. And so this, I really wanted to share this out so that everyone understood from the agency side, not the K-12 side, what all teachers in California are really working with or trying to work with. This is new, and so teachers are looking for examples of what does this mean if I'm asking questions and defining problems through the lens of patterns or one of these other areas. And obviously we could go through all 7 of these and talk very thoroughly around fire as a phenomenon with every one of these cross-cutting concepts. And this again is how it's framed. They use this color coding. The DCIs are in the orange and the cross-cutting concepts are in the green. So this is just some of the branding and some of what teachers are looking at as it comes to them. And it also breaks down those physical, life, and earth and space sciences into smaller areas and parts as the kids go through the different grade levels. There is a 4th area you'll notice off to the side with the disciplinary core ideas in engineering, technology, and the application of science. Those are interwoven through the physical, life, and earth and space sciences. So I just really wanted to, again, bring this forward so that it's really clear what we're talking about when we're talking about next generation science. Next, really, is environmental literacy. This is that 4th piece that California has made a significant commitment to do. And actually, all curriculum being developed in the state of California has to include this environmental literacy component. And so when you think about fire is a phenomena, fire is an issue, and you go through these 5 principles that are in front of you, clearly, it pops out very quickly. People depend on natural systems for ecosystem services, for water, for timber, for all sorts of different pieces. We depend on these things, and fire is also a part of a natural system. People influence natural systems, and we have influenced our forests and our ecosystems to the current context of where we are with forests and fire. And then you can see principle 3, natural systems change in ways that people benefit from and can influence, which is right there in the heartbeat of what we're talking about with fire and fire management. Principle 4 being that there are no permanent or impermeable boundaries that prevent matter from flowing. So we talk a lot about carbon cycles and things like that, and there's a lot of opportunity with respiration, studying these things that could be studied in isolation from the environment, but instead can be studied through the environment and through what's going right outside the door. And then finally, principle 5 is that decisions affecting resources and natural systems are complex and involve many factors. Of course, we know this, and fire is right in the thick of that plot. The last thing I really want to share around next generation science here in the California Science Framework are these 3 bullets in front of you. The idea that when teachers are teaching science, it is 3-dimensional instruction, so that students will engage in scientific inquiry of phenomena using all 3 dimensions. So they'll be using those cross-cutting concepts, those disciplinary core ideas, and those scientific and engineering practices. We want this to be coherent across the curriculum, the idea that kids will encounter the same learning again and again, but going into greater depth as the kids get older. And then finally, this is a very important one, relevant to local communities and student interests. We know that if you get kids outside into the field, it's an engaging place for kids to be. And we know that fire is very relevant to local communities. Whether you are paying attention to it or not, we're constantly reminded of our vulnerability in our communities and our lives with the ever presence of fire in the state of California and everywhere. And so the bottom paragraph really emphasizes that it needs to extend beyond the classroom, for sort of lines up from the bottom. And so there's a real emphasis out of Sacramento Department of Education to really beat the drum of, we want kids to be applying their science to where they live and the things that are happening around them. And so ultimately, as we start to look at that, we really bump into this area of phenomena. The inquiry of phenomena around us is the driving part of next generation science. All of the curriculum coming forward emphasizes phenomena as the way in. And so obviously we can study fire as a physical science phenomena through chemistry, through combustion, and there's that whole side of inquiry with that. But then there's also fire as it is on the landscape and the ecosystems and part of life cycles and fire adapted organisms. And so there's that whole big frame of the inquiry of phenomena. Also kind of tucked right underneath that are the ideas of tying phenomena to compelling issues. They normally are naturally wedded to each other, but a lot of teachers are using a compelling issue or a driving question related to an issue or a problem in a community or in the environment to launch kids into phenomena. And then lastly, I just wanted to frame that phenomena, as it's being taught and emphasized in science classrooms everywhere, is really broken down into two different types of phenomenon. One of them is anchor phenomenon, which we could simply just say anchor phenomenon that we're talking about here is fire. And it anchors down in a very large area of study, a huge thing that has a lot of ramifications. But underneath the anchor phenomenon are the investigative phenomenon. And again, I only put 3, but we know that there are probably 303 different investigative phenomena that you could study related to fire. And we're going to be getting into some of these. I just kind of wanted to frame that phenomena piece because that is a core element of what all teachers are looking at as they're doing next generation science. The last thing around what our K-12 science community is looking at right now all over the state is, as they are looking to do next generation science, 3-dimensional instruction, and integrating those environmental principles and concepts using phenomena and issues. And in our situation here, we're talking about fire, is that all of the lesson, all the curriculum is actually broken down to an instructional model called 5E. It's really, really simple, but they decide to strip it all the way down into just understandable subsets. And so the idea of when you're taking students through the investigation of a phenomena, you have to attend to the engaging of the students so they're into it and they care about it. From there, you move into exploring, investigations, and all those pieces that would be a part of exploring. As kids explore, they then are seeking answers and solutions, collecting data in order to explain the phenomena that they're bumping into and they've been exploring. As they learn new things, they'll have new questions, and so there are lots of opportunity for elaboration and extending beyond what the initial engagement was, and then constantly evaluating student learning through this whole process. And this is not a linear 5E model. The idea of 5Es is that we're constantly looping back and feeding back into this engage, explore, explain process as we go through. So again, just something to make really clear. I often just simply say 3D and 5E are two things to remember really clearly when it comes to K-12 science education and engineering in the state of California. And this goes beyond the state of California as well. Actually, I wanted to just double check. There are other things also going around, happening societally right now around focusing on getting kids outside. And I just wanted to touch on this briefly. The Children in Nature Network, which was inspired by Richard Louve's work and of Last Child in the Woods. They have many different initiatives they're working on. One of them is green schoolyards and the idea of just getting kids outside. So there's a lot of research going on out there about the benefits of having kids learning about where they live, learning about things that matter to them and are relevant to their lives. So I just really wanted to emphasize this piece. And also just a lot of literature coming out. Jerry Lieberman's work, Education and the Environment, and Stanford recently did a significant analysis of 119 different peer-reviewed studies that all show the benefits, the positive benefits of environmental education for K-12 students. And this is getting kids outside and applying their learning to where they live, and just the power of all of that. So I'm now going to move a little bit more into sort of the next section of this webinar, which is getting into where we're at. And obviously the subtitle of this webinar is teaching, K-12 NGSS through one of California's critical phenomena and issues. Now, obviously, this is not just a California issue; it's nationwide. And I'm going to touch nationally here and there, but I'm going to stay fairly true to the California pulse on this as well. Just to honor that title and that expectation that was put forward. But this is a CAL FIRE graphic that I co-opted just for this webinar. Just we know up and down the state, from East Coast to West Coast, or sorry, from the eastern side to the western side and the north to the south, fire is an ever part of our lives, no matter where you live. It does not matter if you're urban, suburban, or rural. While it may be tempered differently, it's critical all the way through. And actually, I just pulled up an InstaWeb today, just like what's going on in California, and there are 3 fires, even though technically the fire season is over on the 28th of October in California. There are 3 fires that are, small scale, but 3 fires that are burning right now. And it is a part of our daily pulse. And while there is our cyclical patterns of fires in our areas, we know it is an ever-present piece, especially when we're waiting for that first precipitation to really come and descend upon us. A couple of other little pieces that also came from CAL FIRE, number of fires in acres. I just wanted to highlight a few of these little pieces. Just in this past year, we had 620,000 acres burn, and there's a lot of really good information on there, and it's really important for kids to look at real data and be using non-fictional sources of literature to be able to gather their information. So these are just a couple of pieces that I pulled out of CAL FIRE. Top 20 largest California wildfires, of course, 2 of the largest were in the 2 of the last years. But on this list of 20, 16 of the 20 largest fires have all happened in the last 20 years. So we know, we've heard anecdotally, but we also know with the data out there, and it seems like from news report to research article, there's constant substantiation that fires are getting more catastrophic. And, so not just, the amount of fires we're having, but the severity of those fires as well. And then just, flagging here nationally again that whether you're looking to the National Interagency Fire Center, there's many places. Fire is ever present when we're talking about land management, especially forested areas. And so I just wanted to share a couple little pieces from the national database. If we look at, just the last 10 years, the acreage burned nationally, 8 million, over 8 million acres burned in the last 2 years. And obviously we can sort of see a little bit of ebb and flow there, but our acreage is high. And this is a phenomenon, an issue that isn't, the phenomena will never go anywhere, and really the issue will not either. So back again, I don't want to sort of play the media role of trying to show that everything's catastrophic with fire, because it certainly is not, but it is an attention piece for what we do. So I'm just going to share a little bit about the Plumas Unified School District's partnership at the Plumas National Forest and what we've been doing up in our area, only as an example. a model of what other areas can do. And again, a national forest is not the only fire entity or agency to partner with. There are, fire safe councils and fire departments. Defensible space and fire is an area that's is an aspect of everyone's community and culture. And so there are many ways to build partnerships like this. But we had an opportunity after the Story Fire occurred in 2000 in our area to partner with the Forest Service as a school district to help them to do their restoration work that was related to the fire. And then we could also use that as a catalyst for education. And so we formed a partnership with a participating agreement that moved us forward. And for some reason, my slides are jumping around just a little bit. But our strategic goals were education, restoration, and community. We wanted the kids to become land stewards and work on fire restoration activities. And by so doing, enhance their education by working on real world issues. On the education side, our focus is 3rd through 12th grade, K through 2 at the primary age. While fire certainly is something that can be brought forward, it's not something that we would put kids in the field around. But we want to give our students natural resources experience through innovative methods, all of these different pieces, and foster stewardship and environmental literacy through the entire experience. And ultimately doing restoration of natural, cultural, and recreational resources and attributes throughout the entire fire footprint down there. So we had a particular opportunity because of some fire settlement funds that came through the Story Fire to have some funding to help us to really launch a lot of this. And I know not everybody has that opportunity. And so I just want to sort of acknowledge that up front. I just want to share some of these different projects that we do, working on trails in the area, in the Pacific Crest Trail and Feather River Canyon. Several of our campgrounds burned up, and so our local wood shops in our schools helped to build them back up, put in fencing, and built other attributes that the campgrounds needed. We did a lot of endemic, we have some greenhouse programs, and so we're also to propagate seeds and support endemic plant propagation, and then planting out in the field, working on tree planting, also doing a lot of noxious weed control that came through all of that, also fuels reduction work. And so we have averaged actually 50 field trips a year over the last 8 years with the Forest Service, going out in the field through 3rd through 12th grade, doing different projects with the Forest Service. And I know that Ron Logan, who is on this webinar right now, one of our teachers, certainly went on his lion's share of those as we went out and did many different types of projects. And Ron, I would invite anything that you might want to say about that. The one thing I would simply interject is that our goal all along was to make sure that our fire education was happening in the communities and around the school. So for every field trip, you might be able to put kids on a bus and go far away. The funding for those kind of field trips ebbs and flows and comes and goes. And so it's really critical that anything that we have kids learn about fire in our community, in our region, that we're able to bring it back home. This is we've taught basic 32 courses through our schools as well, preparing kids for vocational opportunities, and ultimately lots of good positive project outcomes. Every student is involved every year through 12th grade through their science program. We've done over 400 field trips to date, 23 senior projects, as you can see. Over 20,000 volunteer hours have been a part of this. And the Forest Service asks us to track that and share that out. And lots of professional development and vocational opportunities for our students. And then ultimately, through the restoration outcomes, we've done a lot of work that the Forest Service tracks from what we do in the field with them, because ultimately we're helping them to achieve their stewardship outcomes. And if you want to learn a little bit more around this, this bit.ly link, bit.ly/fireplumas, would allow you to see a lot more. We have videos and a lot of other information and data related to this particular program. And then finally, lots of teacher workshops to move our teachers' understanding and knowledge in being effective in the classroom. And so ultimately, we've had the opportunity to do a lot on public land with the Forest Service, always wearing personal protective equipment and following the job hazard analysis pieces. But one of the most important things that came out of our partnership with the Forest Service was the decision to develop a curriculum. And we did not want to recreate the wheel, and we looked out there and we saw the fireworks curriculum that the Missoula Fire Lab had created. So we approached them about developing a curriculum just for the Sierra Nevada, something for California, because everything prior to that time had been innovations for other areas of the West. And so actually Melissa Groh, who is also on this webinar right now, she's the teacher in one of these pictures. And they, both Ron, Logan, and Melissa helped to pilot this curriculum and test it out, work in the classroom with students around this curriculum, as well as field opportunities. And Melissa or Ron, is there anything that you would like to sort of share around this particular curriculum and how it has benefited you or your students?
Sure. Hi, Ron and Rob and everybody out there. My name is Melissa Groh, and I worked with the curriculum with a group of third graders and piloted it last year. Prior to that, I did work on bits and pieces of it, but working with the Fire Effects Laboratory and Alana Abramson, and then the curriculum coming through to the Sierra Nevada Fireworks curriculum. Last year, worked with 3 people through the Forest Service. The tall guy in that picture right there, that's my son, and he was the district fuels officer on the Beckworth Ranger Station. I had parents that I worked with. One of them was Michelle Copoletta. She was ecologist for U.S. Forest Service, and Kristen Winford, the assistant district silviculturist. And they would come in, Michelle and Kristen would come in every couple of weeks, and we worked through the curriculum. My son, Marty theirs, would come in, and he came in multiple times, worked through parts of the curriculum with the matchstick forest, and took us on hike through the Toll Squirrel fire footprint toward the end of the school year. And it was a great partnership where my students learned a ton across all parts of the curriculum: English language arts, writing, math, science, social studies, art, and we actually did parts of it I considered PE as well.
Awesome. Yeah,
Hey,
Ron.
This is Ron Logan, and I attended a few fireworks training workshops and used the curriculum mostly in a high school natural resources class. It is really well put together, and of course I added, a little more local flair to it because I had been doing that before. But there were so many places within that curriculum that you could jump off and dive deeper into physical science or more life science and environment. So I didn't use it as much with the middle school. I will say, there are opportunities for the cross-curricular development, like Melissa said, a bit more challenging at the high school level when we have our classrooms and we're still set up with kind of 15-minute subject-specific classrooms. But I really loved having that curriculum there to use and then to kind of dive off from it at various different points.
Thank you, Ron. I know Ron also mentioned to me that he also used another resource that's really strong in California. There are 85 units that were created in the last 15 years by the Education and Environment Initiative, EEI. And so we call it the EEI curriculum. If you're not familiar with it, please Google and look it up. but they have 85 different units, and one of the science units is on the carbon cycle, and I know that Ron used that after using fireworks to kind of drill a little bit deeper into that aspect of science. I know there's also a history, 6th grade history unit as well, the EEI unit, that talks about Native people's use of fire. And so there's many other resources out there, some of that I'm going to allude to here in a few minutes, but I just wanted to kind of grab that little teachable moment. Lots of resources out there. We didn't want to recreate anything, and we didn't, but we definitely partnered with Alana Abramson and Jane Smith from the Fire Effects Laboratory to really make the most of their work. And then they spent a ton of time making sure it was Sierra Nevada and California relevant. I'm going to actually add a couple of other little pieces here. So fireworks, the program comes out of the Rocky Mountain Research Station, Fire, Fuel, and Smoke and Science Program, and the Fire Modeling Institute, of which fireworks educational program is a part. So it's kind of a lot of scaffolding there to drill into this. But the Sierra Nevada fireworks curriculum is not the only one. So if you're coming on this webinar from other places in the West, just know that there are also other iterations of this curriculum. This particularly, this curriculum, the fireworks, Sierra Nevada fireworks, has an elementary, middle, and high school versions of it where there's some repetition, just like we're supposed to be doing in Next Generation Science, where you have the same units that are touched upon in each of those 3 grade bands, but obviously the complexity and the depth to which teachers and students go is much greater. And so this is a wonderful resource if you have not used it or looked at it yet. I just, again, wanted to kind of give deep value to Alana and her work and the fireworks educational program. But you'll notice here on this snapshot of this website that there's also fire in the Rocky Mountains, and I believe I actually teased that out here. There's not only the Sierra Nevada fireworks, but Northern Rocky Mountains and Northern Cascades, Sagebrush, Missouri River Country, which is the prairie country to the east of the Rockies, and also a Native American curriculum as well, looking at the Blackfoot Native American tribe and how they also carried fire and used fire. And we know that that's true of many Native peoples, but they have this one particular example. There's also some other versions of it being worked on in the state of California that I want to make sure everybody knows about. UC Cooperative Extension and working with some of the cooperative extension agents in the last couple of years, fire is definitely being emphasized a lot. So working with Susie Coker, also a number of other individuals in the state. Right now, I'm not looking to do this, but there are individuals who are working on an oak woodland version of fireworks that is primarily focused on the foothills, but also will have application to coastal oak woodlands as well. And we're looking at, and they're looking at a few other options as well. I'm just one member of this group that's trying to stoke the fires of fire education. But I just wanted to acknowledge those pieces so that there are things that you can be aware of. So the last little piece that I wanted to bring forward is just this idea again, fire as the phenomenon that we're looking at as the anchor phenomenon. But the investigative phenomena, there are many, many opportunities. And ultimately, I knew that a 1-hour webinar was going to be difficult to wrangle all this detail. So I'm going to go through these next ones quite quickly, but you will all be getting a copy of these. And just know that everything that I pretty much have in these next parts, these next slides in the slide deck, have come from the fireworks slideshows that Alana put together, so you can reference that. So when it comes to different investigative phenomena, we have weather and climate. So that is a particular subset of fire that students can look at closely about fire and weather and how weather will drive fires, as well as climate change. And so, these slides that I'm sharing right now are actually from the Sierra Nevada fireworks curriculum, using the story fire that happened in our region, just as a case study to share this out. But certainly anyone's fire from any other area could be used in the same way, and just swapping out the incident reports. And you can see, you can follow that link to check out other details around some of this. But just using weather, there's a lot of information. Obviously, a lot that can be studied around fire and weather and the correlation of what's going on when a fire blows up, or when we're able to get ahead of a fire when we're attending to a fire. Also with prescribed fire, what is it about the weather and the conditions on the ground and in the air that will allow a prescribed fire to occur? And so they use data from this Carpenter Ridge remote access weather station to really sort of tell this story. And again, I'm not spending a lot of time on it. There are also some other pieces in the fireworks curriculum talk about the changing temperatures going on, and how that and climate and the changes in climate can be correlated as well to all of this. And so I'm just doing a quick reference here, just in the spirit of time, but these are all in this slide deck and all in the fireworks curriculum. And this is not an easy to read fire slide right here, but just talking about, and you can certainly follow the graph to talk a little bit about the change in fire, the Western fire season, how much longer it is now. Saying it's 78 days longer since 1986, which is remarkable and significant, obviously, for any land manager, and having kids look at why that is the case. Obviously, when fire occurs, then we have soil impacts. So another investigation around fire would be soil, and looking at, was it a mild, moderate, or severe fire? There's a lot of information also in the fireworks curriculum that helps kind of lead students through looking at soil closely and the impacts of fire severity on the soil. The duration of heat. So severity is not just the amount of heat, but also duration, how long it sits there and cooks there. And so here are just some photos that are a part of that slide deck. And then, of course, once soil is disrupted, the impacts when weather then comes in, and we have impacts to watershed and all of that. So another investigative phenomena, erosion all by itself after a fire has occurred, and going out and setting up monitoring in those areas. Another investigative phenomenon is smoke. This is a satellite image from the rim fire. And obviously a picture's worth a whole lot of words, but we know weather and fuels really drive that. This is also from the fireworks curriculum. And you get into some of the science of smoke, how many microns in diameter a single particle of smoke is, and ultimately how that plays out with particulate matter in the air. And again, this isn't a teacher workshop, so I'm not able to go into great detail with all of this, but just really wanting to represent some of the breadth and the depth of what's covered in the fireworks curriculum and looking at changes of air quality and particulate matter. Pulling this around, another investigative phenomena being heat transfer and fuel properties. This keeps jumping around me a little bit. This is actually another one on smoke and inversion, teaching the kids about inversion, which is also a phenomenon that kids can view, and they can see it in urban areas with smog, and they can see it related with fire. So you can really see this in all different areas of California. As I was starting to point out, heat transfer and fuel properties, heat being transferred through convection or radiation, two different phenomena also that can be investigated by students. And then some of the details around the transference of that. Really quite fascinating things. Another investigative phenomenon, fire severity. I'm kind of skipping some things here in the slide deck just to kind of, so that you can see everything here. But this fire severity obviously is contributed a lot by the fire triangle and the fire behavior triangle. And not everything is high and severe. We have different severities all the time. And then the related significance to vegetation, soils, wildlife, as we look at some of these. And again, these slides are all pulled from the fireworks curriculum. And then, of course, there's the aftermath, having kids going out after a fire and being looked at, an area and determining what the severity was just by the response and the succession that occurs after a fire. So just showing some different images that are available through all of that. And of course, other aspects within that investigative phenomenon for science, next generation science with forest succession would be, insects coming in. When are the insects coming in? What are they doing? Of course, we have other aspects of forest succession, the arrival of like the black, black-backed woodpecker, and primary cavity nesters, also fire adaptation of different plants, and how fire, these plants have been adapted over many years, thousands of years, to live with fire. I'm just acknowledging the fact that we have 10 minutes left in the webinar. And so what I want to do is I'm just going to quickly skip through a few more slides. Then I'm going to back off so that Stacy can kind of pull in any questions. The investigative phenomena of fire frequency, a lot of people are familiar with endocrinology, and there's a lot of fascinating things to look at the fire frequency that occurs in different areas of California. In our own area, I've been able to work with local people. This is our ranger district, the Mount Huff Ranger District, and looking at how often fire has occurred, but looking at the historical framework of most of the forests had burned every 10 to 19 years, with only a few exceptions. And then, of course, this has changed significantly as fire suppression has occurred. And then just a couple of side-by-side photos. There are photos like this all over the state of California, looking at 100-year-old photos and what has changed over time, looking for that evidence for students to be able to do. It's just really key for schools to be able to partner with agencies and those who have access, and academia and colleges and universities that have access to a lot of these resources that teachers really don't know where to begin with. And then, of course, some of the high severe fires that are coming forward. This is just a little bit more locally exampled as we come through. Here we have a photo of after the 2000 fire, right before it burned again in the 2012 Chips fire, and then just watching fire succession as the frequency comes back. And then just one little sort of like a little side interjection. A friend of mine who is a fire ecologist asked me to kind of put this thing forward from Stephen Pine. He says, every fire put out is a problem put off, which is an interesting idea to put forward to students. Fire is inevitable and essential, but how do we wrangle all of that? Especially as we know more, more and more of the budget with federal appropriation is going towards fire management rather than other aspects of the national forest management, if you look at the comparison between 95 and 2015. So there's lots of ways to enter these phenomena, these discussions, and these issues, looking at management, looking at appropriations of dollars, looking at just direct impacts, but a lot of all these. But ultimately, I really want to tell you all, because most of the people on this webinar are agency people. Schools are looking for fire science partners. Very few, nationally, only 5% of kindergarten through 6th grade teachers have a science degree. And so there's a lot of anxiousness, anxiety around teaching science. And so having a curriculum is very helpful, but also having a professional to help you wrangle these issues, these questions, a go-to is really important. And it doesn't have to be the Forest Service. If you live in an area where the Forest Service is not located, partnering with CAL FIRE or your local fire district or a fire department or a fire safe council. There's the California Fire Safe Council, but then there are also fire safe councils in lots of communities. So here's just public parks and public lands, and every one of these land management units all are looking at fire. This right here is just an image of fire safe councils all over the state of California. So, every school has a local entity. So if you're an agency reaching out to your schools, I really hope you've come to understand a little bit more of what schools are looking for in meeting the idea of fire as part of the curriculum. And educators, I'm hoping that you're also looking here that there are lots of resources, lots of agencies and organizations out there who can be an ally and a support to you. Whether you're teaching fire science right on your school campus, or if you're looking to go a little bit further out to get onto fire affected areas, there's many opportunities. Lots of resources out there. This is like smokeythebear.org. Obviously fire suppression has in part gotten us where we are, but Smokey's message is constantly tweaking around, and it's about fire is also beneficial. There is a link page here that Sandra Derby from Project Learning Tree in California helped me put together. It has many resources for Project Learning Tree, as well as other resources at the bottom. You'll notice for Texas, Oregon, and also the whole Southeast that was put together by NC State. with many, many links from all these different spots. So some of these are curriculum links. Some of these are just links to more curriculum and resources. We wanted to make sure that you had connection and access to some of these links, like on NCWeb, to follow some of these different pieces. So I apologize, I accelerated a little bit here at the end. As I noted, our time was running out. I do want you to know that all of those resources are there in the slide deck for you to peruse more slowly. I'm available to answer any questions anyone might have in follow-up, as part of my funding in my position with the County Office of Education is also to support the Sierra Nevada Fireworks and fire education in the state of California. So I'm happy to work with any other agency, any other individual and teacher, educator in the state to help them with any of these things. Stacy?
All right, thanks so much, Rob. And I'll also want to give a thank you for all those great photos. We don't always have webinars with things actually happening on the ground and photos and evidence of that. So thanks so much for that. I'm going to take a quick second. We do have time for questions. And then if people want to, we're going to stay on a little bit longer to keep those questions going if we need to. I just wanted to point out two things. So first of all, I will be sending up a follow-up email with the link to the recording for this once it's ready. All of the links, the PowerPoint, anything else that might be of use to you guys. So look for that in the next week or so. I also want to point out that there is a quick evaluation survey. This really helps us to know what kind of webinars people are looking for and to report back to our funders to let them know that these webinars are useful and we want to keep doing them. So that takes less than 5 minutes probably, and I'll send that link in the follow-up, but it's also there on your chat box. So we do have time for questions. Please send those in by just clicking the questions button and then submitting whatever you'd like. And I also wanted to point out one thing, that as we were going through this, you had a list of partners with potential to connect with educators like the Forest Service or CAL FIRE. And we also have a lot of people on this call who are at universities. And so I know here at UC Berkeley, where I'm stationed, we have like an outreach program that we send people to K through 12 classrooms for an hour or something. So also maybe reach out to, if you're an academic person and you're interested in doing fire science, you can use some of this and go into classrooms by reaching out to your school districts, and vice versa. If you're a school district or an educator, think about connecting to any of your local community colleges or universities that might have people who are excited to leave the lab and go see kids for an hour. So just wanted to point those two things out. I think so far our first question we're going to go with is, if you're living in California in a not Sierra Nevada place, how adaptable is this curriculum beyond Sierra Nevadas?
Okay, well, when we worked with Alana to do this, one of the things we wanted was a relevant outcome. We didn't want to just hoard the opportunity to have a curriculum that looked like us. And so I know one of the things that Alana and Jane tried to do in the development of fireworks was to generalize it enough that it was very modular. So if you have a case study of a fire in your area, you can just remove that and put the same data or profile of a fire in your own area. So definitely they took real steps to try and generalize the curriculum. Certainly all the physical science aspects of fire science are relevant everywhere, all over the world. And so that would not need to be changed at all. And then just different aspects of the curriculum, studying smoke, studying soil impacts, those are not specific to the Sierras. It's a little bit more when we get into wildlife and plant communities that there's a lot more definition. But again, that's fairly modular, and you can substitute some of your own plants and animals to make it more localized. And as I mentioned too, there's 2 other efforts right now in the state of California to make other versions, so that we have a coastal version, we have a foothills version, and so we have more specificity for everyone's benefit.
Excellent. It looks like we do have Alana on with us right now. So she's from the Missoula Fire Lab. They have a link that's specifically generic curricula. So if you're not in the Sierra Nevada or you're not one of these regions that's served, it looks like there's a place you can go to and it's all in one place. So I'll include that link as well in the follow-up email. Our next question is, so far you've been working with this program for a while. What's the biggest challenge you've seen in actually integrating it into the classroom?
Well, I think the biggest issue is sort of 2-part. In the elementary school classroom, the biggest issue is that science has not been commonly taught effectively in the elementary school, at the elementary school level in K-6. And so the idea of even teaching any science is fairly new. And then to teach something that is so specific and even sort of challenging, the idea of fire, how do you bring that forward? So I think a lot of it is just sort of a little bit of the anxiety or the reaction to the idea of doing fire education at the elementary school level. That's why having a professional, whether it's your local fire department coming in to help, or local community college or local university coming in to help, can be very, very helpful for those K-6 teachers. So I just know those teachers are moving very slow at becoming more science literate and comfortable in teaching science and then teaching fire science more specifically. At the high school level, the challenge is just that most schools are set up in 50-minute teaching periods. And so that's not a lot of time to get down into the forest duff and potentially ash around all this stuff. And so, on the one hand, we have all of these field trips we've done, but we know that they're not sustainable. We're not going to always have money to send kids off on these big field trips that came from fire settlement funds. So part of it for us was just wrangling those expectations that if we can't apply it to our local campus and our own community, then we know that it's not a long-term solution to fire science and fire education. So we've constantly been working on tempering some of that. Our science teachers are wonderful science teachers. They know their areas, but it's just using these hands-on labs and some of the field applications of fire science, which was, has been more challenging and new to any of that. And I don't know if Ron or Melissa want to say anything about either of those pieces.
Well, I'll just add that I think the fireworks program and curriculum is it's a wonderful and can be a starting point to break off to several different, like you use the term investigative phenomena, where a teacher would want to go deeper into any of those specific subjects. And so challenges are 50-minute periods, but at the same time, the curriculum is broken up and it's segmented so that you can fit those in. And I think it fits really well into these next generation science standards, and will become more and more useful as teachers become more comfortable with it and use it.
And I would echo what Ron just said. With the elementary, we were doing about a 50-minute block, 50 minutes to an hour. And I do know that there was some hesitation with dealing with fire. I had a team teacher and she was awesome. She was open to my suggestions on anything. And with the partnership with the Forest Service, that helped alleviate those anxieties that she and I were, here we are dealing with third graders and bringing in fire and talking about that. But there was so much across the curriculum that our students were able to learn and write about and read about. It was quite an amazing science year. For third grade, it was called the Year of Fur and Fire. We integrated it with our mammal study and what was going on with our mammals, and through the different seasons and weather, in addition to when fire would move through their particular habitat. So lots of really deep learning that went on there.
Thank you both.
With that, it looks like we're actually through all of our questions. I'll also mention that I'll put emails into the follow-up. So if you want to follow up, directly afterwards, that's great too. But unless if any of our presenters have something to add, I think we'll call it a day.
I think I will add one thing, Stacy. Thank you. Right now, we've been working with Alana Abrams, and when I say we, I really do want to give acknowledgement to Sandra Derby with Project Learning Tree in California, and also UC Cooperative Extension, several natural resources advisors through the University of California Cooperative Extension system are involved in really supporting this K-12 work. And we've done an annual training in Blodgett Forest, of which we're looking to do again in April. So that's something that any educator or supporting entity could look to attend. But the other thing that we're hoping to have occur with Alana, which we haven't firmed up yet, is to actually have Alana come out here to California for a week or two this next summer, not only to do trainings in a few of these areas where we're often running, but to make sure that we have her go to some different areas around California. And I know we're working on some grants to help to fund that, but the idea is we want to support an hour-long webinar, which is just a tease in many ways, with some more dominant, significant training of a day or 2 or 3 days in different areas, so that anyone who's interested in really going further with K-12 fire education and NGSS really can do that. So I just want everybody to know we're working very hard at that, stoking that fire. No pun is intended, and looking forward to supporting any of you that need it or want it.
And Rob, if people are interested in, either doing the training or that sort of thing, what's the best way to connect? I'll mention that I know on the California Fire Sciences Consortium, we're happy to post that as an event. People know about it from our newsletter and that sort of thing. But is there some kind of list or other way that they should connect with you on that?
It would probably be, since I'm one of the 3 people with their, contact information on this webinar, you can start with me, and I can certainly then share out any interest with our larger group. And then as we get that a little more locked in, we'll have a better way of kind of one-stop shopping.
All right, that sounds like a great plan. Anything else from today?
Nope, thank you all, and just appreciate everyone's participation, and want to thank Ron and Melissa for getting on here. And ultimately, we tapped into them very slightly. They both have much more to share, and I definitely dominated the webinar itself. But please follow up if you have any questions, and I think Ron or Melissa would be willing to have a conversation with anybody who wants a little more detail about how this plays out in the classroom at a school on a more day-to-day annual basis.
Absolutely, Ron. I'd be happy to help anybody.
Great. And thank you, Stacy, for an awesome webinar.
That was great. Thanks so much, everyone. Take care.
Thank you.